I'm Vlad Fomitchev, and I interned at Harris this summer. If you're not familiar, Harris is a government contractor for communication systems. So that includes everything from military comms to sat comms and basically anything that sends a signal somewhere. So my internship consisted of two main projects. The first one was a independent research project, which is basically something that Harris wanted to research to possibly implement into some of their technologies at some point. So the first one was a blockchain on Raspberry Pis that would run over a mesh network. So some of the goals with this that they had in mind was they wanted to create this mesh network on a bunch of Raspberry Pis, set up a blockchain, and then see if they could use that blockchain to send trusted and or like verified commands. So it's a kind of alternative to digital signatures in a way. And another thing they wanted to try was to be able to send sensor data and send just files over the blockchain, which was kind of a bizarre idea, but yeah. So also, in case you're not familiar with blockchain technology, it's basically the same. It's the technology that powers Bitcoin and Ethereum, if you've ever heard of the various cryptocurrencies. So essentially, it's a kind of a digital ledger of sorts that uses cryptographic hashing and signing to ensure validity. So they wanted to kind of test this technology. So the configuration we ended up having was 4 Raspberry Pi, 3 B pluses with dual band Wi-Fi, which was nice. We just ran on Raspbian OS, and on them we ended up setting up Ethereum with automatic peer discovery. So all these Raspberry Pi Ethereum nodes would be able to find each other automatically over the mesh network. And we would use Python with Web3 and JSON to interface with it for the most part, aside from the Go Ethereum JavaScript console. So we created a private Ethereum network for this that ran on our Raspberry Pis. And for this, we had a 5-second block time, which is how quickly new blocks, how quickly transactions are put into new blocks. So it's like the refresh rate of your network, basically. And we had Ethereum actually doesn't have a block size limit, but it has a gas limit. And the gas limit we had used was roughly equal to 2 megabytes per block. So that's that basically determines how many transactions you can put into one block, depending on their size. And another unique thing about our network that we had created was that it's actually proof of authority instead of proof of work. So you may have heard that Bitcoin mining and stuff takes a lot of power and energy and is very computationally intensive. And so are all most cryptocurrencies. But we wanted to kind of avoid that problem since we would be running on Raspberry Pis and they don't have a lot of computational resources. So actually, this system signs blocks cryptographically and then assumes that whoever signed it is a trustworthy source. So you don't have to constantly run hashes on every transaction and every block to verify it. You're relying on the trustworthiness of the node that signed the block. So it's a trade-off in security in a way for less power consumption. So the tasks that we ended up completing with this were setting up the mesh network, setting up a blockchain. We were able to use Python to send commands. I designed a script that would break data into chunks and send it as transactions as well. And also made another program that would send sensor data, specifically in this case it was wireless signal information across the blockchain. But we ended up, I ended up taking it a step further actually because I had time. I also ended up designing an Ethereum smart contract and applying this to a small cognitive radio concept. So for the first thing that I had tried was I had written a Python script that would connect to the Ethereum client and send various data. So you would specify a file that you wanted to send, and it would break it into 32 kilobyte chunks, and then send each of those chunks as a transaction on the blockchain. And that is actually a hard-coded limit in Ethereum, so you can't go above 32K per transaction. But you can just break a file into a bunch of chunks. And on whatever node you wanted to receive this file on, since every node will always sync the blockchain. Once you send a file onto the blockchain, you can technically download it on any node as long as the blockchain has been synced. So on your desired receiving node, you could run a script that would basically pull those transactions out of the blockchain and stitch the file back together. So we ran a few tests on this. It was pretty interesting. Speed overall, the throughput was quite low, which is to be expected with so much overhead of breaking a file apart and sending it through something that's not designed for sending large amounts of data. So basically we were around 200 kilobytes per second for most tests. And actually, if you were to repeat this test on the live Ethereum network at the time when I got that data, Ethereum was worth $410. So to send a 3 megabyte file would have cost $86 to send on the live network. Or if you sent a 52 megabyte file, it would have cost over $1,500. Fortunately, we were on a private network, so we didn't have to worry about that. Yeah. So the next kind of thing that I tried to kind of tie all those other tasks together was a idea for distributed decision making. So I designed a smart contract that would facilitate voting. So one of the things that makes Ethereum unique from other cryptocurrencies is that it is able to run distributed code on nodes that are participating in the network. So you can launch code written in a language called Solidity, and you can call it with a transaction. So you basically send a small fee, and whoever mines your transaction will actually execute your code. So it's interesting because it effectively means that since the blockchain is immutable and transactions have to be confirmed by multiple nodes, it's kind of a trusted execution source. You know that the result of your code is guaranteed to be accurate and nobody could have tampered with it. So I thought this would be an interesting thing to use as a voting arbitrator. So basically, what it allows you to do is nodes are able to send votes to this contract, and every 15 blocks, whenever a vote is sent in, the contract will tally up the votes that it's received and return the one with the most votes. So it's a vote by majority. And what we use this for is voting for a wireless channel. So the cognitive aspect, the cognitive radio aspect that I mentioned earlier ties in here, where I designed a couple more scripts, a Wi-Fi scanner, a message sender, and a message receiver. So basically, the wireless scanner will scan for wireless networks in the vicinity and record which channels those networks are on, and then use a very primitive algorithm to rate the channels, basically, and it would rate channels based on how empty they were. So the more networks were present on a wireless channel, the more points it would subtract. So effectively, the algorithm would return an output of the clearest channel. And what I would do is I would send that result to the smart contract, and I had all the nodes do this. So they would use the message sender to do that, which basically would just send a JSON string into the blockchain that could then be picked up by the message receiver, which would be constantly scanning the blockchain for messages, and it would display what other nodes are voting for, as well as the telemetry that other nodes were sending to the blockchain, and act on smart contract decisions. So as nodes would be voting for a new wireless channel, every once in a while, the smart contract would pick a winning wireless channel and emit that as a command. So once that was posted to the blockchain, the nodes would pick it up and see, okay, we are going to switch to channel, say 36 at 8:30 a.m. And all the nodes would switch to that channel. And they would continue voting. So if someone else moved onto that same wireless channel, they would likely try to move somewhere else. So the idea was kind of a proof of concept of trusted commands and trusted execution using the blockchain. So overall, I'd say we were pretty successful in the goals that we had set out to do. And we were able to send files, send commands, send the sensor data, which in our case was the Wi-Fi signal strength, demonstrated some decision making. Overall, our supervisor was satisfied with the project, but it was pretty much shelved. So it may or may not be revisited in the future by them. It depends on what they need. But I guess the biggest lesson I took out of it was actually learning to communicate the importance of an idea to higher-ups. Because I felt like there was a lot that could be done with this concept, but it was difficult to explain because the people that actually wanted this project done, I felt, didn't really have a good understanding of what blockchain was and what its merits were, and what kind of applications would work well on it. And I tried to demonstrate that as in the best way I could, but wasn't quite able to. So I guess that's something to keep in mind for the future. But yeah, so that first project was ended after about a month. So the second thing I worked on was with a different branch of Harris in the wireless products group. And actually, unfortunately, I can't really talk much about it because it's mostly confidential. So all I can really say is that I was tasked with something related to Wi-Fi and smartphones and wireless authentication. So basically it involved a lot of low-level 802.11 protocol research and a lot of Python programming. And unfortunately, that's all I can really tell you about that project. I wish I could say more. I honestly, it was way more in depth than the previous one. But overall, at the end of the project, my supervisor was really happy with it. And the software that I had made will probably be used in some of the, or at least in development of Harris devices and products. And actually in that process, I did a lot of Python programming, and it involved a small command line interface. And I ended up doing a lot to add like help UIs and as much documentation as possible to that interface, and that actually made a big deal. Well, apparently was a big deal to like some of the people that my supervisor was presenting our work to. And so I guess I realized the importance of having a user-friendly interface, because even as my supervisor had told me, it's kind of like the difference between them actually, being willing to use the program and just kind of going, yeah, this looks difficult, I don't want to. But yeah, aside from that, it gave me a really good understanding of 802.11 and wireless protocols in general. I got to do a lot of really low-level research on that, and it was very interesting overall. But yeah, that's basically it. That's my links that I used. That's all she wrote.
What else?
Yeah, let me just ask him a question, make sure it's all fair. And one, I guess, the comment is that it's it's good work, and just like the other folks who participated with this internship presentations. I think improvements would be like simple things like slide numbering, just to help with people keeping track of slides.
Yeah, that actually got broken because I made the PowerPoint in Open Office on Linux and I exported it to
Gotcha.
Microsoft and it erased them. I had like a whole border at the bottom. I don't know when I did that.
Well, that's something to think about for the future, because it's a simple thing that, it's certainly not for you, obviously, because you know everything. It's gonna be for the people trying to keep track of things, if they're trying to write down questions. Oh, I had a question on the slide, something.
Yeah, it should have been there. I actually should have looked at the PowerPoint, but I didn't look at the converted one beforehand.
One thing that's it's good, you talked about a lot of good content, especially around standards, and I think another area of improvement is the formatting of the references at the end. It just seems like something that may not be important, but when you're, like if you're ever dealing with somebody who has to send this document somewhere, if somebody were to get feisty about details, like their communications people, when they go through a document to see if it hits all the legal requirements to be distributed, one of the things is things being properly referenced. So
Yeah, I probably should have done proper citations.
right, so I think in general it looked good, but those are some of the things. And then always rehearsing presentations and stuff. Good work. Thank you.